Okay, good afternoon. Welcome to T Mechanical Part Second. Today we will see the subject Machine Design 2. It is having lecture 3 hours per week, practicals 2 hours per week, ICA, that is term work marks, 25 marks are there, in semester evaluation 30 marks, and end semester evaluation 70 marks. That is, university examination is of 70 marks. It is having code of ME 321. 3 means third year, 2 means second semester, and 1 means first subject. Now we will see course introduction, that is introduction to machine design. This course seeks to provide an introduction to design of various machine elements and discusses various design procedures, requirements, and design methods. It introduces the design procedure for various types of gears like spur gears, helical gears, bevel gears, and worm gears, along with the introduction to AGMA standard. AGMA means American Gear Manufacturing Association. A further content explains in detail the significance of pressure vessels, design procedure, and introduction to various standards used for pressure vessels. The different types of bearings, their significance, and the selection of the rolling contact bearings from manufacturer's catalog, and the design considerations for sliding contact bearing are also included in the course content. Therefore, this is overall information of this course. Course means subject. Now, what are the prerequisites for this course? Already you have studied in first year applied mechanics. In second year you have studied strength of material, that is mechanics of materials. Then in second year semester 2 you have studied theory of machines, that is kinematics of machines, that subject is there. Then in third year semester 1 you have studied machine design 1. Therefore, whatever knowledge you have gained from all these four subjects, that knowledge is beneficial while studying this subject. Also, you have studied how to draw gears, that is their IS convention. You have studied that part in machine drawing. Also, you have studied AutoCAD software. In that, you have studied how to draw these different components. Therefore, already all the basic things you have studied, so that there will not be any difficulty to study this subject. Therefore, what is the course prerequisite? Student shall have knowledge of function of different machine elements, such as different types of gears, bearings, shafts, keys, etc. A sound background of mechanics of material and fundamentals of design of machine elements is essential for successful completion of this course. Now we'll see course objectives. During this course, student is expected first to design gears and pressure vessels. Second, to select bearing from manufacturer's catalog. Third, to use standards in design of machine elements. Course outcomes. At the end of this course, student will be able to first design gears and pressure vessels. Second, calculate the load acting on shaft to select bearing from manufacturer's catalog. Third, use standards in design of machine elements. Now we will see detailed syllabus. First, section 1. In that, unit 1 is spur and helical gears. Number of lectures required is equal to 11. Now in that, first is spur gear. Now we will see its unit content. Design considerations of gears, gear materials, types of gear tooth failures, hunting tooth, gear tooth loads, minimum number of teeth, face width, Levy's equation, then Spott's equation, Buckingham's equation, only introductory treatment, then gear design for maximum power transmission, and introduction to AGMA code. AGMA means American Gear Manufacturing Association. In that, second part is helical gear, virtual number of teeth, force analysis, beam and wear strength, effective load on gear tooth. This is the unit 1. Now unit 2, pressure vessel. Number of lectures required is equal to 6. Now these lectures are as per university curriculum. We may require more lectures as compared to this. Therefore, unit content of pressure vessel is thin cylinders, in that types of stresses, design of thin cylinders, numerical treatment will be there. Thick cylinders, types of stresses, failure criteria, in that Lamè's equation, Claverino's equation, Birney's equation, numerical treatment, no derivation. Then introduction to compound cylinders, auto freightage, unfired pressure vessels code, types of enclosures. For types of enclosures, there is no numerical, only theory will be there. Then effect of opening and nozzle in shell and covers, numerical treatment will be there. Then introduction to ASME codes used for design of pressure vessels, introductory treatment. Then unit 3 is statistical considerations in design. Number of lectures required is equal to 3. Now unit content is frequency distribution, probability distribution, normal curve, design, and natural tolerances. Now, section second, unit 4, wheel gear. Number of lectures required is equal to 5. Its unit content is terminology and geometrical relation, force analysis, mounting of bevel gears, beam strength and wear strength, dynamic tooth load. Next, unit 5 is worm gear. Number of lectures required is 5. Unit content, terminology and geometrical relations, materials, standard dimensions, and recommendations of worm bearing, force analysis of worm drive, friction in worm gear, efficiency and design criteria of worm drive as per IS 7443 1974, load rating of worm drive, strength and wear rating of worm wear, then thermal considerations in worm drive. Now, unit 6 is rolling contact and sliding contact bearing. Number of lectures required is 10. In that, first is rolling contact bearing, types, static and dynamic load capacities, Strybeck's equation, equivalent bearing load, load life relationship, bearing life, load factor, selection of bearing from manufacturer's catalog, ball and roller bearing, designed for variable load and speed, bearings with probability of survival other than 90%, lubrication and mountings, dismounting and preloading of bearings, sliding contact bearing, bearing material and their properties, bearing types and their construction details, hydrodynamic lubrication, performance analysis of hydrodynamic bearing by Raimondi and Boyd method. Introduction to hydrostatic bearings. It is only for introductory treatment. Therefore, these are 6 chapters in your syllabus. We have to study all these 6 chapters. In each and every chapter, there will be numerical examples. First of all, I am going to solve one type of numerical example and I will provide you 2 to 3 examples based on that type. Now, ICA, that is internal continuous assessment, that means term 1. In that, they have told us to design and drawing using design data book. First is gearbox or pressure vessel. Therefore, out of these two, we will design any one, that is either gearbox or pressure vessel. Now, second part is assignments, minimum 5. First is spur gears, second is helical gears, third is bevel gears, fourth is worm gears, fifth is rolling and sliding contact bearings, sixth is pressure vessels, seventh is design and natural tolerances. Eighth is study of different codes. Therefore, this is your term one. Now, textbooks. What are the textbooks and reference books are required for this subject? First is Design of Machine Elements by V.P. Bhandari. Second is Machine Design by Robert L. Norton. Third is PSG Design Data Book. These are the textbooks. Now reference books. First is Design of Machine Elements by J. E. Shigley. Second, Design of Pressure Vessel by Harvey. Third, Machine Design by Hall, Polovenko, Shom's Outline Series. Fourth is Introduction to Tribology by Muzumdar. Therefore, this is your syllabus, including term work, textbook, and reference books. Now, we will see what is meant by machine design, what is the importance of machine design in your curriculum. Therefore, machine design. What is the importance of machine design for engineers? Now, before starting this importance of machine design for engineers, I will tell you definition of machine. Already you have studied definition of machine in second year in theory of machines or kinematics of machine subject. What is the definition of machine? Machine is a device which converts available energy into useful work. Therefore, machine consists of different links. When these links are joined together, they are forming kinematic chain. And if one of the link is fixed, then it is known as mechanism. And when all these mechanisms are combined together, it will form a machine. Therefore, already you have carried out practicals on different machines, that is lathe machine, milling machine, grinding machine is there, planing machine, shaping machine. All these machines are there which converts electrical energy into mechanical energy. Similarly, our IC engine is also one type of machine because it also consists of different parts: crank, connecting rod, cylinder, and piston. Therefore, engine converts chemical energy into mechanical energy. Chemical energy of petrol, diesel, or maybe in nowadays CNG gas is there or LPG gas is there. Therefore, these are the fuels which is having some chemical composition. Therefore, chemical energy of these fuels is used to run the vehicle. That is, chemical energy is converted into mechanical energy. Therefore, engine is also one type of machine. Only in case of engine, chemical energy is used as input. In case of machine, electrical energy is used as input. Now, what is the importance of machine design for engineers? What is machine design? That I have told to you. What is machine? Now, design means what? Design means to construct new things. Design means to construct new things or to build new things or to manufacture new things. That means machine design. In machine, you are knowing there are different parts which are connected to each other, and there is relative motion between different parts of the machine, and these different parts are transferring forces. Now, design means what? Creation of new and better machines and improving existing ones so that it is economical in the cost of production and operation. Now, how a design is born? First is creation, next is sorry, how this design is created. First of all, we have to check market requirement. Now, example of design I will tell. Now, before arriving of this smartphone, now we are knowing in today's smartphone, camera is there, FM is also there. Also, you can see the pictures, you can make the videos, so that there is no need of the our earlier cameras. Now you are knowing that earlier Kodak film is there. Kodak film was there. They have not understood the market requirement and they have not changed according to the market. Now you are observing that in the market everyone is using mobile phone with camera. You will not see Kodak films or Konica films. That companies are now they are not existing. Same is the example of Nokia company. Earlier only Nokia brand was there in mobile phones. They have not understood the requirement of the customer and they have not changed according to the market. At that time, Samsung came. Samsung realized the requirements of the customers and they have introduced different smartphones which includes camera, FM, many more things, and that too at low cost. And you are now observing the result that in the market no one is buying the phone of Nokia company. Means that is the result. We have to understand the market requirement and according to market requirement we have to design our product. Now this is creation means new design. For this market requirement we have to search the market, what are the requirements of customer requirements, then we have to create a rough idea model. How we are creating a model? We are taking the ideas from the market or from the customer. Then what we are doing? We are doing market survey so that if we'll create the model, whether it is marketable or not, or whether customers will take it or not. Similarly, we have to see aesthetic, that is how that product will look like so that customers will attract towards the product. Then ease of handling. We are knowing that mobile phone or any product should be user friendly. That is known as ease of handling. Then safety. There should be safety features. Then it should be economical. Then it should be recyclable. Then whenever whatever these different points we are going to consider, we are creating model, and to create the model actually we require availability of funds and available material, that is which material we are going to use to manufacture that product, and that material should be also of low cost, because you are knowing that whenever we are manufacturing the product, nearly 60 to 70% cost is of material. And next is manufacturing process, that is which manufacturing process we can use to manufacture that product. Therefore, like this we are creating the new design, and when we are creating the new design or new product, we are carrying out its analysis. Then in analysis, what we are studying? We are studying what are different forces or stresses are there on the product. Then materials used, then sizes. Means we are manufacturing that product in different sizes. Therefore, this is the overall design procedure. Now we will see this design procedure according to the products available in the market. Now you are knowing that there are different car models are available in the market. Now before entering of the Maruti Suzuki company in the market, there were only one car or two cars were there in India, that is Ambassador and Premier Padmini. You may be knowing or you may have heard these names of two cars. Ambassador, you are knowing that old model was there, and it is of only block shaped. Uh, Also aesthetically, it was not looking good. Then when Maruti Suzuki company came, then that Maruti Suzuki company introduced different car models in the market. That is Maruti 800. Now it is converted to Alto. Then Wagoner, Swift Desire is there. Then Brezza is there. All these car models Maruti has introduced because they understood the requirements of the customer. And if you will observe carefully, all these shapes of the cars, whatever Maruti has introduced in the market, these are of aerodynamic shapes. And if you will compare that design or that aesthetic look of Ambassador, it was not that much aerodynamic. And that's why customer attracted towards the Maruti Suzuki company, and you will not find any Ambassador car on the road now. Same is the case of all other companies. Therefore, we have to take into account different aspects from the market, that is aesthetic, ease of handling, safety, economical, recyclability, which manufacturing process we have to use, material, funds, then we have to carry out analysis, then we are creating the new design or new model. Therefore, this is nothing but the design procedure, how design is born. Now, what is the basic knowledge required for machine design? First is mathematics, second is engineering mechanics, third is strength of materials. Engineering mechanics consists of mechanics of machines, mechanics of materials, fluid mechanics, and thermodynamics. Now, next is workshop processes and engineering drawing. Engineering drawing consists of machine drawing also. Then next process is computing, and next is finite element analysis. In that computational fluid dynamics also we have to study. Therefore, basic knowledge of all these subjects we require for machine design. Now, important considerations in machine design. First is type of load and stresses caused by the load. In that, dead loads. Dead load means weight. Always remember, dead load means weight, self weight. Then live loads. Live loads means what? Load of wind, because wind is blowing. Therefore, whatever that velocity of wind is there, it does not remain constant. It always varies. Therefore, that wind load will always vary, and that's why that wind load is known as live load. Similarly, in case of rainy season, when heavy rain is there, then more load will be there, and when no rain will be there, when heavy rain will be there, then more load will be there, and when no rain is there, therefore no load. That's why that load of water or the force of water or force of wind, these are known as live loads. In case of live loads, further classified as steady loads and variable loads. Wind load and that water load is there, that are known as variable loads. Now, shock loads. Shock shock means force. It is sudden load. When you are feeling this shock load, suppose your vehicle or our vehicle is going on the road, and suppose there is a ditch on the road. Therefore, whenever our vehicle will pass through that ditch, what we are feeling? We are feeling shock, sudden shock on our back. That is known as shock load. Now, impact loads. It is applied with some velocity. Impact load, you can consider its example of rain. Rain is also one type of impact load. Then next is stress and strain. There are different types of stresses and strains. Tensile stress, compressive stress, shear stress. Strain is unitless quantity, your name. Strain means change in dimension upon original dimension. In stresses, you have to consider again thermal stresses, because whenever there will exist heat, at that time thermal stresses will come in picture. Then torsional stresses. Torsional stresses are coming in picture when parts are rotating because of torque. Torsional stresses are produced. Bending stresses. Bending stresses are produced due to bending moment. Now, second is kinematics of machines. Kinematics means motion of the parts. Therefore, find the simplest arrangement that would give the most efficient motion that is required. Now we have studied different types of motions in theory of machines or kinematics of machines. First is completely constant motion, next is incompletely constant motion, and next is successfully constant motion. Now you have seen that whatever motion should be there, that motion should be only in one direction. Then and then we can transmit motion from one part to another part, or we can transmit force from one part to another part, because motion should be in only one direction, and that example is nothing but completely constant motion and successfully constant motion. Next is selection of materials. Now you are knowing, while designing the any part or any component of the machine, we have to take into account different types of materials, because cost of the material constitutes 60 to 70% cost of the product. That is, major cost is of materials. Now you are knowing that because of this COVID-19 effect, production of steel is decreased. If you will go in the market and if you study the rates of steel material, whatever today they are there, and whatever prices are there of the steel material in the last month, or maybe in the December or in January, you will find that as compared to rates of steel in the month of December or January, rates of steel material which is used for construction work is increased in the month of February. Therefore, because of this increase in prices of the material or steel material, cost of houses or homes is also increased. Therefore, you have to take into account material cost also while designing the product. That is, knowledge of the properties of different materials and their behavior under different working conditions is required. Similarly, strength, hardness, durability, flexibility, weight, resistance to heat and corrosion, electrical conductivity, machinability, etc. These are the different parameters you have to take into account while selection of materials. Now again, selection of materials. There are two types of materials, metal and non-metal. Again, in case of metal, ferrous metals, that is iron base, non-ferrous metals. Physical properties also have to consider: density, melting point, electrical and thermal properties. Mechanical properties such as strength. Strength means resist externally applied loads without breaking or yielding. Stiffness, resist deformation under stress. Elasticity, regain original shape once the force is removed. Plasticity, property which retains deformation which is required for forging. Ductility, ability to be drawn into a wire biotensile force, then brittleness, sudden breaking with minimum distortion, toughness, resist fracture due to high impact load, creep, deformation under stress and high temperature, fatigue, ability to withstand cyclic stresses, hardness, resistance to wear or scratching or deformation or machinability. Therefore, another another important consideration in machine design is form and size of the parts. Form means shape. Form means shape. Use of I-beam or angle. The size will be determined by the forces or torques applied and the material used such that failure would not occur. Now, general procedure in machine design. First is need or aim. This need we are collecting from the market. Recognize and specify the problem. Next is second step is synthesis. Select the mechanism that would give the desired motion and form the basic model with a sketch. Next is analysis of the forces. Next is material selection. Next is design of elements. In design of elements, we are determining the stresses and thereby the sizes of components so that failure or deformation does not occur. Now these are interrelated. All the steps are interrelated and last two steps are also interrelated. If the product will fail, again we have to select the material which is having higher yield strength suitable for the product. Again we have to design, we have to calculate the stresses. If it is safe, then we will decide that material for that product. Then last is modification. Modify sizes to ease construction and reduce overall cost. Then next is detailed drawing. We have to prepare detailed drawing of the product which you have studied in case of assembly and detail chapter. In detailed drawing, assembly of product will be there and detailed drawing of product will be there along with the part list. And last step is production, that is manufacturing of the product. Now we will see significance of design of components. I think today we will stop here. Next lecture we will see significance of design of components, and again I will revise the things. Now I request you to type your roll number in the chat box. Thank you very much.